So let's talk about the intuition behind the formula for conditional probability. So what I have here is a Venn diagram with two events, A and B. Right? Now recall that the probability of an event is equal to the number of ways the event happens divided by the total number of possible outcomes. So we're interested in the probability of B given A. If you apply this formula to this context, this is just going to be the number of ways B happens given A has happened divided by the total number of possible outcomes. Okay. And I'm going to put an asterisk here in the denominator because it will turn out that the denominator will not be the same as what we've been seeing. Okay, but we'll get to that. Okay? Let's talk about the numerator first. So the numerator is the number of ways that B happens given that A has happened. This means that the numerator is the same as the number of ways both A and B happen. Okay? Let's think about this for a second, right? We know that A has happened and we want B to also happen. That can only occur in sample points such that both A and B happen, which is the number of ways both A and B happen, right? Now, let's look at the denominator. The denominator is the total number of possible outcomes with an asterisk. Why do I have an asterisk? Here we are conditioning on the fact that A has happened, right? That allows us to restrict our attention to just cases where A has happened. And so if you look at the Venn diagram, in a sense, we don't care about the rest of the sample space. We only care about the part of the sample space where A happens. So we're gonna ignore the shaded area. Right? We ignore the whole shaded area and we only care about whatever happens inside the green circle. Okay. Should be orange. And so we ignore the shaded part. And so in this situation, the total number of possible outcomes is just the number of ways A happens. Right? And this is because we condition on A. So this is going to be equal to what? the numerator is the number of ways both A and B happen. That is just gonna be the intersection of A and B, right? So this is the number of sample points in the intersection of A and B divided by the number of sample points in A. So technically we could just end the formula right here, right? And be done with it. But to make things more convenient, we want to express things in terms of probability, right? And in order to express things in terms of probability, we can divide both the numerator and the denominator by the total number of outcomes in the entire sample space, right? So the numerator becomes the number of sample points in the intersection of A and B, right, divided by the total number of outcomes of the experiment, and the denominator becomes the number of sample points in A, right? So number of sample points in A divided by the total number of outcomes of the experiment. But by definition, the numerator then becomes the probability of the intersection of A and B, and then the denominator becomes the probability of A, right? And that was precisely the formula for conditional probability. So in this video, my goal was to explain to you the intuition behind the formula for conditional probability, how we got from the definition of the probability of an event from up here, right, to the final formula down here.